So now we are going to discuss about the LU factorization. So we can look into the definition of LU factorization now. But before moving to that, we all are familiar with the word factorization, right? We learned about the polynomial factorization. Here you can see one example. Suppose we have a second degree polynomial x square minus 5x plus 6. Then we can split it as the product of two first degree polynomials, that is x minus 3 into x minus 2, and this is called the factorized form. Similarly, a square matrix can be factorized into lower triangular and upper triangular. When we multiply that, we will get the original matrix itself, and that is called the LU factorization. And here in the right side you can see in the yellow box that lower triangular means all the elements above the diagonal elements is 0. All the elements above the diagonal is 0. And for upper triangle it is opposite. All the elements below the diagonal is to 0. So from a given matrix we have to convert this upper triangular and lower triangular form to express as in the factorized form. For that we are using Doolittle's method to find the LU factorization of a given matrix. So let's look into the Doolittle's method now. So for Doolittle's method, there are two steps. We have to create the upper triangular matrix and also we have to create a lower triangular matrix. For first, we have to construct the upper triangular matrix using the row addition step, that is to zero out the entries below the main diagonal of A. So in order to make all the elements below the diagonal to 0, you have to use this row addition that is described in the Doolittle's method. Now after getting this Doolittle's method, after getting the upper triangular matrix, you have to form the lower triangular matrix. For that, you have to write the identity matrix corresponding to the given matrix A. That is, if the question is some 2 by 2 matrix, you have to write the 2 by 2 identity matrix. If it is a 3 by 3 identity matrix, 3 by 3 matrix is the question, you have to write the 3 by 3 identity matrix. Then we have to choose the value of C from the row addition step. Then we have to record minus C to the corresponding entry in the identity matrix. Then we have to continue this procedure based on the row addition steps in U. Finally, we will get the lower triangular matrix. So this is the method. Now we can go to the problem. So given A equal to 6241, we have to factorize this matrix. So it can be factorized by using the LU factorization definition, that is A can be written as L into U, where L is the lower triangular matrix and U is the upper triangular matrix. Now by Doolittle's method, first we have to create U, then we have to create L. So in order to create U means it is the upper triangular matrix, that is all the elements below the diagonal level must be 0. So we have to make this 4 to 0. For that we have to apply the row addition method. So the transformation is R2 is changing to R2 minus 2 by 3 R1. So when you apply this transformation or row addition step, the matrix will changes to 620 minus 1 by 3, which is an upper triangular form. So this will be considered as U. Now we have to form L. The given matrix is a 2 by 2 matrix. So first we will consider the identity matrix 1 0 0 1. So we have to make this into lower triangular matrix. Lower triangular matrix means all the elements above the diagonal will be 0. So above it is okay, but below the 0 we have to convert that to some number. To convert that, we will take the C value in the row addition. So here C value is minus 2 by 3. and we have to change this number. So we will take the opposite sign of 2 by 3 and replace that 0 by that number. So that will change us to 1 0 2 by 3 1, which is L. So A can be written as L into U, where L is 1 0 2 by 3 1 and U is 620 minus 1 by 3, which is in the factorized form. Now we will look into some application of LU factorization. So we learned about how we can solve the system of linear equations using the matrix method, then by using Gauss elimination, Gauss-Jordan method, etc. So this LU factorization can also be used to solve a linear equation. For that, first of all, you from the given set of equations, suppose this is our set of equation, then you have to create A, B and X as we studied earlier, and it is clear that every matrix can be written in the form of, every equations can be written in the form Ax equal to B. But here instead of A, we know that it is the LU factorization we are going to apply there. So A can be taken as LU, so this we can write it as LU x equal to B. Now to solve this equation for x, first of all we will take this part ux equal to some y, then we will write it as Ly equal to B. Then we solve for this part first, after that we will apply the given part to ux equal to 5 to solve for x. So maybe if I think it will be difficult when you go through this definition part, but it will be clear once you go through the problem. So this is the question. We have to solve this equation using LU factorization. So we have to identify A, B and X first. A is the coefficient of all the x, y, z in this equation. B is the right part and unknown values forms the capital X, that is x, y, z. Then you have to find the L and U by using Doolittle's method in this from this matrix A. Then you have to follow the procedure as I'll discuss in the problem. So we got A, X and B from the above question. Now we are going to solve this equation by using LU factorization method. So as you can see this, the question itself, you have to apply LU factorization. That is, you have to convert the given matrix A into the form L and U. A has to be converted into form L and U. So similar to the above question, you have to find U and L by applying Doolittle's method itself. So we can start with that. First, the given matrix A is, it is, I'm just rewriting here, 4 minus 2 1 minus 4 1 2 12 1 3. So I'm going to find a U from this matrix using the Doolittle's methods. So to find U, as I said already, we have to make all the elements below the diagonal to 0. That is, we have to make minus 4, 12 and 1 to 0. So similar to that Gauss elimination method, I already teach you how we can find out the transformation to make one number to 0, 1, etc. Like that you can apply here also. So that first of all we have to convert this minus 4 to 0. So there is a 4 above that. So if we add them, it will convert it to 0. So we can write R2 changes to R2 plus R1. Same way we can convert this 12 by using when you multiply the first row element by 3 and then you subtract with 12, it will changes to 0. So that transformation can be written as R3 changes to R3 minus 3 times R1. So from this we will get the transformed matrix as 4 minus 2 1, 0 minus 1 3, 0 7 0. So after this step you have to convert this 7 to 0. So there is a minus 1 over that. So if you multiply that minus 1 with 7 and add them, you will get that number to 0. So we can transform it as R3 changes to R3 plus 7 times R2. So it will transform to 4 minus 2 1, 0 minus 1 3, 0, 0, 21. Now we can see that all the elements below the diagonal are 0. So we will get u from this. So this is our u. Next you have to create L. To form L, the given matrix is a 3 by 3 matrix. So you have to first write the identity matrix 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1. Then you have to make this into lower triangular, which means all the elements above the diagonal will be 0, below it must be some number. So we have to make these numbers, that is 0, 0, 0 to some number. So we will start with the first one. The first one can be transformed to some number by using the first transformation. So here the coefficient of second part is, that is 1 R1. So the value of C is 1 there. So you have to replace that given matrix by -1. So first three elements will be same. This can be written as -1, 0, 0. Now we have to transform this element. So that we have to consider the second transformation. Its C value is -3. So take the opposite sign, that is 3. Then after that you have to change this 0. So that we have to take the third transformation. So in that C value is 7. So you have to take it as -7. -7, 0. This will be our L. So we got L and U. Then we have to replace L and U by this given matrix. So this, up to this, the factorization method is there. Now we have to apply the we have to solve this given equation using this factorized matrix. So we got L and U. Now we are going to factorize this. So as you can see that we can write a given matrix in the form AX equal to, given equations in the form AX equal to B. This is our formal notation. But using LU factorization, we can replace this L and U, A by LU, X equal to B. And some conditions are also defined in the definition that we can apply throughout this problem. So we are going to write what is L first. We got L as 1, 0, 0, minus 1, 1, 0, 3 minus 7, 1. Then U is 4 minus 2, 1, 0 minus 1, 3, 0, 0, 21. Then X can be written as here X, Y, Z equal to B values at the right side of the equations, that is 7, 7, 28. So this is our notation. Now we are going to consider this as our ux part, u, and this is our x. We are going to take this value as y. Okay, so this can be replaced like this. That is 1, 0, 0, minus 1, 1, 0, 3 minus 7, 1 into, this is replaced by y. So I am writing it as y1, y2, y3 equal to 7, 7, 28. So we will get the matrix like this. Now we have to matrix multiply this two equation, that is 1 into y1 plus 0 into y2 plus 0 into y3 will give you y1 equal to 7. Second equation you will get minus y1 plus y2 equal to 7. From the third equation we get 3y1 minus 7y2 plus y3 equal to 28. So we got y1 as 7. When you substitute that in the second equation you will get y2, then corresponding you will get y3. So substituting all this in the corresponding equations, we will get y1 equal to 7, y2 equal to 14, then y3 equal to 105. Now we are going to replace this. So we substituted ux as y, okay, and then we found out this condition. Now we are going back to this condition, ux equal to y. So we will consider the part ux equal to y. So u is here 4 minus 2 1 0 minus 1 3 0 0 21. X is our x, y, z, and y values we got it as 7 14 105. Then you have to do the matrix multiplication, that is 4 into x plus minus 2 into y plus 1 into z equal to 7. So we get the first equation as 4x minus 2y plus z equal to 7. Second part is minus y plus 3z equal to 14. Then last one 21 z equal to 105. So we will get z equal to 5 here. Then you substitute that in the second equation, you will get the y value. After getting y and z, you can substitute that in the first equation, so that you will get x equal to 1, y equal to 1, and z equal to 5. This is the solution of the method. So in the question, if it is defined like you have to apply, you have to solve the given equation by LU factorization, then only you can apply this. Otherwise, you can follow the methods that we discussed in the earlier classes using the concept of adjoint minor cofactor, or else you can apply the row transformations, Gauss elimination, or Gauss-Jordan methods. So that is the end of this problem. So this is another type of application. You can find the determinant also by using this LU factorization, but the steps are a little bit lengthier when you compare. So from the given matrix A, first you have to find the upper triangular matrix and lower triangular matrix using the Doolittle method. After getting that, you have to find the determinant of U and L. Then you have to multiply them so that you will get the determinant of E. This is the one application. Second application of LU factorization. So problem is as similar. You have to find U and L using Doolittle's method, and you have to find the determinant of both. Multiply that, you will get the determinant of E. So steps are a little bit lengthier when you compare with the determinant of A.